create a small tornado or tropical storm in laboratory. In a video titled Where Do Tornadoes and Tropical Storms Come From?, published on this YouTube channel, it has been explained that tornadoes and tropical storms are developed in 2 steps. First, the circulation of air that includes both inward and outward flows of air is developed. Second, the rotation of the Earth, or the Coriolis effect produced by the Earth's rotation around its own axis, turns these inward flows of air into cyclonic flows of air, which are either tornadoes or tropical storms, depending on the location where they are. The above 2 steps are now simulated in laboratory to create a small tornado or a tropical storm for the purpose of exploring how tornadoes and tropical storms work. The apparatus used to create a small tornado or a tropical storm is quite simple. The major part is the circulatory chamber made of transparent glass, with tiny colored polystyrene balls being added to the inside of the circulatory chamber for ease of observation of air flows. A battery-powered electric motor, Motor 1, is used to drive the circulation of air with the colored balls inside the circulatory chamber. Another electric motor, Motor 2, is used to let the entire circulatory chamber revolve around the axis EF. The apparatus is equipped with 3 cameras. Wireless camera 1 and wireless camera 2 are used to record the flows of air at the bottom and at the top of the circulatory chamber. The third camera, camera 3, is used to record the rotation of the axis EF. Initially, motor 2 is off and motor 1 is turned on. The air inside the chamber together with the colored balls is drawn upward from A to B. When the air reaches the top of the circulatory chamber, point B, it moves outward from B to C, then moves downward from C to D. Finally, it moves inward from D back to A, completing a closed circulation. If only motor 1 is on, while motor 2 is off, the video recorded by camera 1 displays only inward flows of air and the video recorded by camera 2 displays only outward flows of air. This is neither a tornado nor a tropical storm, because tornadoes and tropical storms are cyclonic flows of air. Now, turn on motor 2 to let the entire circulatory chamber revolve around the axis EF. The flows of air at the bottom and at the top of the circulatory chamber are no longer inward nor outward flows of air, but they are now turned into cyclonic flows of air. In view of camera 3, if the axis EF rotates clockwise, what wireless camera 1 and camera 2 view is also clockwise cyclonic flows of air. The reverse is also true. If the axis EF rotates counterclockwise in view of camera 3, what wireless camera 1 and camera 2 view is also counterclockwise flows of air. This means that flows of air at the bottom of the circulatory chamber rotates in the same direction as the rotational direction of the axis EF, because both wireless camera 1 and camera 3 view from below. However, in reality, flows of air at the top of the circulatory chamber rotates in the direction opposite to the rotational direction of the axis EF. This is because wireless camera 2 views the flows of air from above, meanwhile, camera 3 views the rotation from below. This helps explain why tornadoes and tropical storms in the northern hemisphere rotate counterclockwise, but in the southern hemisphere, they rotate clockwise. So, how the revolution of the circulatory chamber around the EF axis turns the inward and outward flows of air into cyclonic flows of air? The answer to the question is as follows. When air moves from D1 to A, the distance from the air to the rotational axis EF increases. Because of the law of momentum conservation, its angular speed therefore decreases. So, it is shifted to the left of the line segment D1A. Similarly, when air moves from D2 to A, the distance from the air to the rotational axis EF decreases, its angular speed therefore increases. So it is shifted to the right of the line segment D2A. Both the increases and decreases in angular speed turns the inward and outward flows of air into cyclonic flows of air. What happens at the top of the circulatory chamber is similar to that at its bottom, but in the opposite direction. At the top of the chamber, air moves outward from the center B to its periphery, which is opposite to the flow direction of air at the bottom of the circulatory chamber. That is why the air at the top of the chamber rotates in the direction opposite to the rotational direction of the chamber. In reality, tornadoes and tropical storms need some forms of energy to work. For tornadoes, source of energy that powers them is heat energy that comes from the hotter ground right below them. For tropical storms, source of energy is also heat energy, but this energy comes from the hotter ocean zones right below them. For this small apparatus, source of energy that nurture this small tornado or tropical storm comes from the work done by the battery-powered electric motor. And the rotation of the Earth is now simulated by the rotation driven by Motor 2.